Stoichiometry and limiting reactants. There's 4 problems that I have on this worksheet, and again, there's a couple different ways that we're going to work these things out, or the different types of problems that are asked. So let's go ahead and get right into it. Question number 1, and let me scroll this up a little bit. Question number 1 says, determine the limiting reactant only. So this problem is not asking for how much of the product's produced. However, even though we're still working with stoichiometry, we still have to go through the 4 steps. Step 1, write a balanced equation. Step 2, change what's given into moles. Step 3, use the mole ratio. And step 4, convert it into the desired units. We're still going to use all 4 of these steps. However, with step 1, we have to predict what the products are as well. So let's go ahead and write down what we know. So it says, determine the limiting reactant only when 75 grams of potassium sulfite. So we have 75 grams of potassium sulfate. And it says it reacts with 61.3 grams of our zinc phosphate. And I put a hint on there that you need to predict the products. So let's go ahead and do step 1 after I went ahead and wrote those values up there. So we do have a double replacement reaction. We have potassium with sulfate, so a metal with a nonmetal, zinc with the phosphate, so another metal with a nonmetal. So those partners are going to switch. So we'll have potassium phosphate. And again, phosphate's a -3 charge, potassium's a +3. So we have 3 of those. And also we have zinc with the sulfate. And zinc in this case has a +2 charge, where the sulfate also has a -2 charge. So that one's written as balanced. So we have the correct charges for our compound, so now we want to balance the number of atoms. This one's the ugliest one. We have 3 zincs and 2 phosphates. So let's go ahead and start with that. So we have 2 phosphates here, only 1 there, so I'm going to put a 2 there. So now I've got 2 phosphate, 6 potassium, but I only have 2 over here, so I'm going to put a 3 there. Now I have 3 sulfates, so I need to have 3 sulfates over here, and then last but not least, 3 zinc, and we're balanced. So step 1, write a balanced equation, and we have done that. Now, with limiting reactants, what we want to do is we want to pick one of the reactants. Doesn't matter which one. And it doesn't matter if we have, say, a volume and a molarity for one of these and a mass for the other. You get to choose. However, make sure that you remember, or that you recall, that whenever you're working these out, that the one that you choose has to be complete information. In other words, it has to be enough information where it will give you moles. So it doesn't matter on this one. So I'm going to go ahead and start with the 75 grams of my potassium sulfate. And again, it doesn't matter. If you would have picked the zinc phosphate, you would still get the correct limiting reactant, but you'd have different values. And we'll have options where you'll see where that works out. So let's continue on with this. So I want to convert, actually let's scoot that over. So I need to convert the grams into moles. So step 2, take what's given, change it into moles. So I have 1 mole of potassium sulfate. And I went ahead and found that mass, and it's 174.226 grams, just to speed things up here. Okay, so again, that right there is step 2, this right here, taking the grams, converting them into moles. So now I have my moles of potassium sulfate. So I'm going to go ahead and put my moles of potassium sulfate down here, because again, I'm looking to determine who the limiting reactant is. So in this mole ratio, I'm going to compare reactant to reactant. So I want to compare moles of each of these to one another. So since I have moles of potassium sulfate down there, I want to have moles of zinc phosphate on top. Okay, so now I need to go back to my balanced equation and plug in the values that I have for my balanced equation for step 3. So in my balanced equation, I have 3 potassium sulfates and I have 1 zinc. All right, so if we were to stop right there, we would have our moles of zinc phosphate. But if I want to compare limiting reactants or determine who the limiting reactant is, I need to get this unit back to a unit that's given to me in the problem. So I need to change this moles of zinc phosphate into grams. So that's what I'm going to do next. So I'm going to go another step here, or step 4, and I'm going to change the moles, and again it's 1 mole of zinc phosphate, into grams. And the grams is 386.11 grams. Okay, so again, just to highlight, step 1, write the balanced equation. Step 2, that's step 2. I've taken the grams of what it is that I started with, and again, I easily could have started with that, but I started with the potassium sulfate, converted it into moles. Then step 3, I'm using the mole ratio, so I get rid of moles of potassium sulfate because I'm looking for moles of my zinc phosphate, so I can convert that into grams. And then step 4 is right there. So let me get a value here. 55.4. Okay, when I do all this calculation, I get 55.4 grams, and again, that is of zinc phosphate. All right, what can we do with this information? Okay, here's how I walk myself through it. Okay, so I know that I have 75 grams of potassium sulfate and 61.3 grams of zinc phosphate, and that was the information that I have. So I have these 2 containers, and that's the amount of reactants that I have. And I want to find out which one is going to be consumed completely first. Whichever one gets completely consumed first, as soon as that reactant is completely consumed, the reaction's done. In other words, it's like, okay, if I'm going to make potassium, or if I have potassium sulfate and I plan on making potassium phosphate, as soon as I run out of potassium, it's hard to make potassium phosphate when you don't have any potassium. Pretty simple. So, here's how I talk myself through it. If I use all 75 grams of my potassium sulfate, I would generate 55.4 grams of zinc phosphate, or I would need, sorry, let me rephrase that. If I use all 75 grams of potassium sulfate, I'm going to need at least 55.4 grams of zinc phosphate. Because again, these are my 2 reactants. So if I'm using all of this, I need at least 55 grams of this. Well, how much do I have? Well, I started off with 61.3. I only need 55, so if I only need 55 and I have 61, which of these will I have left over? Very good. So this is in excess, or I have extra. So I don't want to look at this amount anymore. My limiting reactant is my potassium sulfate. Again, let me say that phrase. If I use all 75 grams of my potassium sulfate, I would need at least 55.4 grams of the zinc phosphate. I have 61. I actually have about 6 grams, just barely over 6 grams more than I need. So I'm going to have extra. When 75 gets used up, I'll only use 55.4 and I'll have about 5.9 grams of this remaining. Isn't that cool? Ish. Looking at question number 2. So go ahead and let's read the question. And not all the questions will have the balanced equations or the balanced formulas given there. You still have to balance the equation. Step 2 says, calculate the number of milligrams of bismuth 3 carbonate. So calculate the number of milligrams of bismuth 3 carbonate. So I'm going to write that above as I'm reading it. That is produced when 45.6 grams of bismuth, so 45.6 grams of bismuth 3 sulfate reacts with 18.8 grams of the nickel 2 carbonate in a double replacement reaction. Then it says nickel sulfate is also produced. Alright, so there's my information. I know this is a limiting reactant problem because I have amounts for 2 different reactants. And the question's asking how much in milligrams of the bismuth 3 carbonate is going to be formed. So step 1, let's write a balanced equation. So I like to look for the ugly one first. Well, we have 2 bismuth, so it really doesn't matter. So I know my bismuth are looking good. So I have 3 sulfates. That means I need a 3 there. So now I have 3 nickels. So that means I need a 3 there. Now I have 3 carbonates. 3 carbonates, I'm balanced. So step 1, write a balanced equation. Step 2, now this problem's a little bit different because the first problem was a limiting reactant step for the reactants only to help me determine who the limiting reactant is. Now I need to know who the limiting reactant is in this problem so I can calculate this. And if I use the excess amount, then I'm getting a fictitious answer because I have to use the substance that is going to run out first. So let's go ahead and pick one. And again, seriously, it doesn't matter which one you choose. Generally I pick the first one just because it's there. Doesn't mean you can't start with the 18.8. So I'm going to go ahead and start with the 45.6 grams of bismuth 3 sulfate. Okay. And again, step 2 asks me, and actually let's scoot that on down. Okay. It asks me to convert that into moles, so I'm going to go ahead and convert that into moles. So move my grams of bismuth down, and again, since this is not the mole ratio, I don't want to write what I have in the balanced equation for this. This is sulfate. Okay. Now I went ahead and did the mass for this, so 706.4 grams. And again, I did that calculation beforehand. I'm sorry, 706.14 grams. Okay. And again, that right there is step 2. However, this step's a little bit different. This is not to solve our question. This is what we call our limiting reactant step. In other words, whenever you have a problem like this, you'll always do what's called a limiting reactant step to find out which of the 2 reactants will be your limiting reactant. So we're going to walk away with some important information here, but it's not going to be our answer to the whole question. All right, so right there's step 2. Step 3, I want to get rid of my moles of bismuth sulfate and go to nickel carbonate. So again, move my unit diagonally. So bismuth sulfate and moles of nickel carbonate. Yeah. And let's get some values there. So I have, looks like a 3 for the nickel and a 1 for the bismuth. And again, these are my reactants, so I'm comparing. All right, so again, this is step 2. This is step 3. Now I'm getting ready to do step 4 in the limiting reactant step. So now I want to get rid of moles of nickel carbonate because my units, my units in the question is in grams. So I need to change, or step 4, change to grams to find out exactly how many grams of nickel I'm going to use. So in this case, it's 118.7 grams. And when we calculate that all in, I get 22.99. So we'll say it's 23 grams, and that is of the nickel to carbonate. All right. So here's how we have to talk this through. If I use all 45.6 grams of the bismuth 3 sulfate, I will need at least 23 grams of nickel carbonate. I only have 18.8. So what this is saying is, in order for me to use all the bismuth sulfate, all 45.6 grams of it, I'm going to need at least 23 grams. I don't have it. So my limiting reactant in this problem is my nickel carbonate. Because again, there's no way I'm going to be able to use all the 45.6 grams because I would need at least 23 grams when I only have 18. So my limiting reactant in this case is a nickel carbonate. Now that we know who the limiting reactant is, I can use this information to answer the question. So the really cool thing is, before we talked about limiting reactants, I never gave you a second reactant amount. Now that we know who our limiting reactant is, and you have to do this step, you just can't guess and hope that you get the limiting reactant. You have to show your audience who the limiting reactant is by doing the steps here. Trust me, these are worth more points anyway. So now I'm going to take my amount that I know. Now I'm not going to use the 23 grams because again, that is to tell me how much I would need if I used all that. So I'm going to use the amount from the question to answer the question, so to speak. So what that means is now I can do my problem. So I'm going to start off with the 18.8 grams of the nickel carbonate. I need to write small. And we will change that into moles again, step 2. So 1 mole of nickel carbonate, and we had that mass just up above at 118.7 grams. Okay, so again, that is step 2. Step 3, let's get rid of our unit moles of nickel carbonate. And in this equation, we're looking for our bismuth carbonate, our bismuth 3 carbonate. So Bi2, CO3, 3. Okay. All right, so let's get some numbers there. So the nickel carbonate has a 3 and the bismuth has a 1. So 3 and 1. Okay. So if I stop right there, that's step 3. That would give me moles of bismuth carbonate. But I'm looking for milligrams, so I need to go at least 2 more steps. Convert the moles. Now again, if we stop right here, our moles of nickel carbonate are gone. Okay? Because again, the grams of nickel carbonate cancel, the moles of the nickel carbonate cancel. So now we're left with this. So let's get, and again, we're going to do step 4 here. So we have our moles of bismuth carbonate. And I did find the molar mass for that to be 597. 597.99 grams. Okay, but we're not stopping there because again, we want it to be in milligrams, so we'll go one more step. Move gram down here, move kilogram right there. Which of those two is bigger? That's right, kilograms is bigger than a gram, and there's 1,000 of those. And when we type all that in, we get 0.0316. Oh, check. Whoa, sorry. This is milligrams, not kilograms. We're looking at milligrams. Sorry about that, guys. So we're going to leave the gram there, but we're going to put the 1 with that, and this is milligram, which is 1,000. Sorry. Okay. So your answer now is 31,000. Actually, let's go 31,600. So I'm going to go 3.16 times 10 to the 4 milligrams. Sorry about that. Okay. And again, recall that all of this, the other way, all of that is step 4. Okay. All right. Let's take a look at number 3. Number 3 says, calculate the number of grams of titanium that is produced. So we're looking for the number of grams of titanium when 200 milliliters of a 2.25 molar solution of titanium sulfite, so 200 milliliters of a 2.25 molar solution of titanium 3 sulfate reacts with 12.3 grams of titanium in a single replacement reaction. Okay, so again, looks like we've got ourselves a limiting reactant problem because yes, I do have complete information. I have a volume and a molarity that will give me moles, and I do have grams that I can convert into moles. So step 1, let's write a balanced equation. Boy, that one looks ugly as all get out. So let's start there. So we've got 2 of those sulfates, 1 there, 3 here. So I'm going to put a 3 there. Now I've got 6 lithium. So there's our balanced equation. It is a limiting reactant problem. So that means I do need to perform what's called a limiting reactant step to find out who my limiting reactant is. And let's go ahead and use the 200 mils here just so you get some more practice. So I've got 200 mils of a 2.25. So if you know the volume and the molarity, always start with the volume. Okay, so we'll convert the milliliters into liters. And remember that 1 liter's much bigger and there's 1,000 milliliters. Okay. And then once we have our volume in liters, now we can use our 2.25 molarity. So I'm going to change that color there. 2.25. And that's moles of, what is it, titanium? Yeah, titanium sulfate. And that's per liter. Okay, so again, all of this is step 2. Okay, so if I know the volume and I know the molarity, start with the volume so that my volume can cancel out. And if I stopped right there, I'd have my moles of titanium sulfate. Okay. Step 3, use the mole ratio. So I need to get rid of moles of titanium 3 sulfate. And I will compare that to lithium. And again, from the balanced equation, I have a 1 and a 6. So 6 and a 1. And the unit that the lithium is in grams, so I need to go to grams. So 1 mole of lithium is 6.94 grams. So let's get a value for that. I think I have that one typed in already. 18.7 grams of lithium. Let me double check that. And that is correct. All right, so, and again, this is step 3, this is step 4. Okay, so, here's how we talk ourselves through it. Okay, let's scoot that on down. If I use all 200 milliliters of my 2.25 molar solution of titanium 3 sulfate, I would need at least 18.7 grams of lithium. Uh-oh. I need at least, how much do I have? 12.3. So what that means is I'm going to have extra of my titanium sulfate because I only have 18, or I'm going to need 18.7, but I only have 12.3. So my limiting reactant is right there. Okay. So what that means is I will use my 12.3 grams of the lithium to answer this question. So that's my limiting reactant step. So again, we're going to start with 12.3. Okay, so 12.3 grams of lithium and 1 mole of lithium is 6.94 grams. So that right there is step 2. So step 3, I want to get rid of my moles of lithium and I'm looking for titanium. So moles of titanium. So again, from the balanced equation, we have a 2 for the titanium and a 6 for the lithium. 2 and 6. And remember, just because 2 can go into 6, don't automatically just reduce that, because later on some people are going to go, where'd that 1 and the 3 come from? I don't have an answer for it. So now the molar mass for titanium, we're going to convert that. So 1 mole of titanium is at 47.9 grams. And that's kind of a straightforward little problem. So let's see how much that is. And that gives 28.3 grams of titanium. Aren't those fun? So again, we had to have a limiting reactant step in this problem because we had 2 amounts for our starting substance. And notice that they're both not grams and they're both not volume and molarity, and that's okay. So find out who your limiting reactant is by using the limiting reactant step. And then once you know who your limiting reactant is, based on the result of your problem here, then use the limiting reactant amount. Not the 18.7. That's often a mistake that a lot of students will do, is they'll use this amount here to go ahead and answer the question for the titanium. This is only an amount if the excess was totally consumed, and we don't want to use that. All right, let's take a look at the last question, number 4. It says calculate the volume of a 4.5 5 molar solution of cobalt-3 nitrate. So looks like we're calculating the volume of a 4.55 molar solution. Now I'm going to stop right there. Do I know both the volume and the molarity? Nope. So this is not information that I'm going to use initially. Cool. All right. When 55.3 grams of potassium reacts in a single replacement reaction, as we can see the products from there. Okay. So let's go ahead and balance this. Well, obviously that's the ugly one. So we've got 3 nitrates, only 1 there. Now I got 3 potassium. Oops. So I put a 3 there, and 1 cobalt, 1 cobalt. We're balanced. Now, is this a limiting reactant problem? I needed to throw a curveball at you just to keep you on your toes. This is not a limiting reactant problem because we don't have complete information here to determine moles. We have a molarity, but molarity is not enough. Molarity alone is not enough to give us moles. We have to have a volume to determine the number of moles. So this is what we're going to use at the end of the problem. So this is our only option. This is our only thing that we know information about. So this is not a limiting reactant problem, even though we have information about 2 things, which is kind of crazy. So step 1, write a balanced equation. Step 2, start with what you know. So we have 55.3 grams of, what was that again? Potassium. And potassium has a molar mass of 39, so 1 mole of potassium is 39.1 grams. And that's step 2, so we have our grams converted into moles. Now I'm going to use the mole ratio. I'm going to get rid of moles of potassium and going to moles of cobalt-3 nitrate. Okay, now this is not a limiting reactant problem, but it is asking for the volume needed to completely react with all the potassium. So it's kind of a limiting reactant problem, but you're not doing a calculation. You're not doing a limiting reactant step. So from the balanced equation, we have a 3 for the potassium. We have a 1 for the cobalt-3 nitrate. Now, again, the steps. Step 1, write a balanced equation. Step 2, change what was given into moles. Step 3, use the mole ratio to cancel out what we started with. So our moles of potassium are gone, and our grams of potassium are gone. If we stopped right here, we'd have moles of cobalt-3 nitrate. But we're looking for a volume here. So since we're looking for a volume, I need to get rid of the unit moles of cobalt-3 nitrate. So I'm going to move that down. So moles of cobalt-3 nitrate. Okay, but what number am I going to put in front of that? I'm going to put the molarity value. Because again, when we talk about molarity, molarity is equal to moles over liters. And if I have a 4.55 value here, what that means is I have 4.55 moles for every liter of my solution. So if I had 1 liter of this 4.55 solution, how many moles do I have? 4.55. So I can invert this and still have it be equal to each other. So I can put the liters on top and put my 4.55 here. And again, when we look at these things are equal to each other, or they represent each other. In other words, if I had 1 mole potassium, it's 39.1 grams. Or if I had the 39.1 grams on top, that would be equal to 1 mole potassium. So these things do represent each other. Even when we look at the mole ratio, it's like saying, okay, for every 3 moles of potassium, I'm going to use 1 mole of cobalt-3 nitrate to make my products. And that's what these things represent. So when you see a problem like this looking for the volume, again, we want to slide our units diagonally if it's not the unit that we're looking for. So we want to cancel those units out. Now, technically, I guess you can put a grams of potassium there to cancel it out. But if I stopped right here, what would my unit represent? Volume. Looks like I'm done. Now, if the question said how many milliliters, go another step. But if it just says volume, stop when you get to a volume. Pretty cool. So let's find out what that's equal to. And in this case, that equals just a little under a liter. So that's 0.104 liters.